Hello everybody. Today we will talk about adsorption and its role in pollution control. Pollution. Pollution is the introduction or presence of contaminants into the natural environment that cause adverse change, harmful or poisonous effects. The three major types of pollution are air pollution, water pollution, and soil pollution. Environmental pollution. Environmental pollution is reaching worrying proportions worldwide. Urbanization and industrialization, along with economic development, have led to an increase in energy consumption and waste discharges. Thus, has a direct impact on the environment and cause pollution. Water pollution. Among the various known forms of pollution, water pollution with contaminants became a global issue, since water is the prime necessity of life and extremely essential for the survival of all living organisms. The largest water pollution sources are organic pollutants, dyes, and inorganic heavy metal. The industries which are declared as the main source of these water pollutants include pharmaceuticals, textiles, dyeing, and meteorological industry, etc. Heavy metals. Heavy metals are defined on the basis of three different criteria, which including density, atomic number, or their chemical properties. Several toxic metals like cadmium, copper, mercury, lead, cadmium, arsenic, zinc, etc. from industrial wastewater and other human activities are directly or indirectly released into the environment. These pollutants from heavy metal are not biodegradable and able to travel up the food chain via bioaccumulation. When the concentration of beneficial metals such as mercury, lead, cadmium in the environment are very high, they will become more toxic. Toxic organic pollutants. Organic pollution is the term used when large quantities of organic compounds. It originates from domestic sewage, urban runoff, industrial influence, and agriculture wastewater. The most common organic pollutants named persistent organic pollutants. Persistent organic pollutants are compounds of large concern due to their toxicity, persistence, long-range transportability, and bioaccumulation in animals. They travel long distance and persist in living organisms. Example: polychlorinated biophenols, hexachlorobenzene. Dyes. Dyes considered as a type of organic pollutants. It is well known that the dye influence from dyestuff manufacturing and textile industries may exhibit toxic effect on microbial population and can be toxic and or carcinogenic to mammalian animal. Most dyes used in textile industries are stable to light and are not biologically degradable. Furthermore, they are resistant to aerobic digestion. Some dyes, methylene blue, talon blue, acid brown dye, acidic red, crystal violet, etc. Pollution control. Several methodologies with varying degree of success have been developed to manage water pollution. This shape show us some example for this method. Coagulation, membrane process, chemical oxidation, ozonation, filtration, adsorption, ion exchange, etc. Adsorption. Adsorption is the most appropriate and reasonable choice for the removal of organic pollutants and inorganic heavy metal ions due to its high efficiency, even at low concentration, low cost, and easy handling, and high availability of different adsorbents. Adsorption is mass transfer process by which a substance is transferred from the liquid phase to the surface of the solid and became bound by physical interaction that characterized of weak van der Waals force and or chemical interaction that characterized of covalent bond, and it may also occur due to electrostatic attraction. Large surface area lead to high adsorption capacity and surface reactivity. Adsorbent types. Different types of adsorbents are classified into natural adsorbents and synthetic adsorbents. Each adsorbent has its own characteristics, such as porosity, pore structure, and nature of its adsorbing surface. Type of adsorbents. Natural adsorbents include charcoal, clays, clay minerals, and zeolites, etc. Synthetic adsorbents are adsorbents prepared from agriculture products and wastes, household wastes, industrial wastes, sewage sludge, and polymetric adsorbents. Some adsorbent. This shape shows us some adsorbent. Activated carbon, bentonite, fly ash, raw kaolinite, activated clay, redwood, organic bell, maize cob, etc. Activated carbons. Activated carbon prepared from agricultural and industrial waste were used for the removal of pollutant from polluted water. The activated carbon used in wastewater treatment is generally prepared from coconut shells, peat, sawdust, wood char, lignin, petroleum coke, bone char, etc. The activated carbon generally exists in the four forms: powder activated carbon, granule activated carbon fibers, activated carbon cloth. Activated carbon. The first research done by Arensi and Huda studied the adsorption of pesticide from aqueous solution into a high specific area activated carbon cloth adsorbent, and found that the maximum adsorption capacity of activated carbon cloth for amitrine, diroine, dinosy, aldicarb were 354.61, 400 21.58, 301.84, and 213.06 milligram per gram respectively. Aldix et al. Investigate the effect of carbon surface chemistry using fibrous 400 activated carbon on the adsorption of three ionic reactive dyes in water. The adsorption followed the following order: rimazole yellow, where its value 1111 milligram per gram; rimazole black, its value was 434 milligram per gram; and rimazole red 400 milligram per gram. McKay et al. Investigate the ability of fibrous 400 for the removal of mercury and chromium ions beside other pollutants. The saturation capacity of the activated carbon was found to be 35 and 138 milligram per gram for chromium and mercury ions respectively. Activated carbon is versatile adsorbent, which can remove various types of pollutant, but its use is sometimes restricted due to higher cost. Natural materials as adsorbents. Various naturally occurring materials having characteristics of an adsorbent are available in large quantities, and their low cost makes them suitable as adsorbents for the removal of various pollutants from wastewater. Chitin is fairly abundant. It is found in exoskeleton of jellyfish and crustaceans. It has been used as an adsorbent for the removal of pollutants from effluents. These two scientists report that the adsorption capacity of chitin for removal the cadmium ion its value adsorption capacity value is 14 milligram per gram. Chitosan, which is produced by alkaline and deacetylation of chitin, is considered more important than chitin for adsorption process. The first research was studied the utilization of chitosan for cadmium removal. They reported an adsorption capacity of 5.93 milligram of cadmium per gram of chitosan at pH range of 4 to 8.3. The adsorption of some other metal for other some metal ion on chitosan was also investigated by Mika et al. In this research, it was found that the adsorption capacity of chitosan for mercury copper, zinc were 815, 222, 164 and 75 milligram per gram respectively. Beet. Beet is another naturally occurring material con containing lignin and cellulose as major constituents. Both et al. studied the neutralization of peat without any treatment for the removal of talon blue. The adsorbent was found to possess adsorption capacity of 16.3 milligram per gram on particles of size 115 to 200 micrometer. These two scientists investigate the adsorption characteristic of peat along with fly ash and bentonite for the removal phenol from wastewater, and found that the removal efficiency is in the following order: the best adsorption or removal by peat, and then fly ash, then bentonite. Sawdust, one of the cheapest and abundantly available adsorbents, has been tried for the uptake of copper from aqueous solution. Sawdust of Mangifera indica manga tree was used as adsorbent. The study thus reveals that the sawdust is an excellent adsorbent for copper removal from aqueous solution. The removal efficiency achieved was 63%. The process is economically feasible and easy to carry out. This investigated by this scientist. Clays and clay minerals adsorbents. One of an effective due to their higher surface area and low cost adsorbent. Modified clays were used as adsorbent for the removal of organic pollutants from wastewater. Two pillared clay were synthesized by intercalation of solution of aluminum and zirconium and evaluated as adsorbents for the removal of organic 2 and methylene blue from aqueous solution. Both clay were found to have the same adsorption capacity when organic 2 was used as adsorbent, whereas the adsorption capacity of zirconium was higher. Its percent was 27 milligram per gram than the aluminum polyrated clays. Its value was 21 milligram per gram for methylene blue. This is from where we take this research. Clays and clay minerals adsorbents. Natural clay evaluate by studying the adsorption of methylene blue from aqueous solution. The material used was purified Morocco clay material from Middle Atlas, Morocco. The CEC of the clay material obtained was 0.2787 milliequivalent per gram. The application of an activated clay mineral as adsorbent for the removal of basic dye methyl blue from aqueous solution was reached at equilibrium 350 mg per gram. The thermal treatment at 300 Celsius for 2 hours and the acid activation with nitric acid of 0.5 mol per cubic decimeter under reflux condition improve the adsorption capacity of the raw clay material. A maximum of 500 mg per gram of methylene blue at equilibrium is achieved. This from where we take this research. And thank you. If you have any question, please ask me.